To illustrate how sophisticated microbes can be, let me share a fascinating story I heard 15 years ago at a psychiatric conference in San Francisco. Robert Sapolsky, a leading expert on the harmful effects of chronic stress on the brain, gave an inspiring lecture on the sinister yet clever microorganism Toxoplasma gondii. In his presentation, he discussed research published in 2000 by Manuel Berdoy and his team at the University of Oxford, which demonstrated that T. gondii has its own survival and reproductive program that it executes in a highly cunning and selfish manner. Although Toxoplasma can only reproduce in one place, the gastrointestinal tract of infected cats, the parasite can infiltrate the brain of any mammal, including humans, by bypassing the blood-brain barrier, a kind of firewall that isolates and protects the brain from unwanted influences. Once cats are infected, the microorganism exits their bodies in their feces. This is why obstetricians and gynecologists advise pregnant women to keep cats and litter boxes out of the house and avoid gardening in areas where cats might bury their feces. In an ideal world for Toxoplasma, cats excrete the parasite, and rodents ingest it, allowing it to enter their bodies. The parasite forms spherical cysts throughout the rodent's body, primarily in the brain. The cat then consumes the infected rodent. Once inside the cat's body, the cyst reproduces in the digestive system, and the newly hatched parasites are excreted in the cat's feces, continuing the cycle. Here's where the story takes a fascinating twist, showcasing the microbe's incredible ingenuity. Under normal circumstances, it would be unlikely for the pathogen in an infected rat to return to a cat, as rodents instinctively avoid predators. However, rodents infected with Toxoplasma not only lose their instinctive fear of cats, they actively prefer areas that smell like cat urine. The parasite achieves this by infiltrating specific regions of the rat's brain with pinpoint accuracy, causing minimal collateral damage along the way. Its target is the emotional operating system responsible for triggering fear and escape responses. This emotional and motor program typically prompts rats to flee at the first scent of a cat, but the parasite specifically eliminates the rat's fear of cats. Infected rats continue to display defensive behavior toward predators other than cats and perform normally on laboratory tests of memory, anxiety, fear, and social behavior. But when it comes to cats, the cysts take things further. They increase the activity of nearby brain circuits that regulate sexual attraction, making Toxoplasma-infected rats sexually attracted to the scent of cats. By triggering a fatal attraction to cats, the parasite overrides the rat's innate fear response with sexual attraction. In other words, infected rats develop a deadly fascination with cats. The evolutionary intelligence behind these strategies is truly remarkable. Pharmaceutical companies have spent billions of dollars developing drugs to perform the same tasks that Toxoplasma accomplishes with ease. Most of these investments have failed. For instance, compounds designed to suppress fear responses in anxiety disorders by blocking the CRF molecule involved in the stress response, or to enhance the libido of women with hypoactive sexual desire disorder, have proven only mildly effective and often come with serious potential side effects. Other microbes have also evolved astonishingly sophisticated methods to influence host behavior. For example, when a host becomes aggressive due to the rabies virus, whether it's a dog, fox, or bat, the virus infiltrates specific brain circuits responsible for rage and aggression. This increases the likelihood that the infected animal will attack and bite another. Or a human transmitting the virus in its saliva to the victim's wound. While the Toxoplasma parasite and the rabies virus stand out for their highly specific knowledge of host neural systems, many other disease-causing microbes, including bacteria, protozoa, and viruses, have developed surprising and ingenious methods to influence host behavior. If a hacker were to manipulate a company's computer system as effectively as Toxoplasma and the rabies virus manipulate the brain, we'd assume the intruder was a skilled hacker with deep knowledge of the system's code, likely an insider. Toxoplasma and the rabies virus have evolved to understand the intricacies of the mammalian gut-brain axis, possess detailed knowledge of mammals' emotional operating systems, and they can manipulate them to achieve their goals.